Northrop Grumman's unmanned, high-altitude, long-endurance, intelligence, surveillance, and reconnaissance systems, or easier said, HALE ISR systems, are based on the proven and highly effective Global Hawk unmanned aircraft system. Developed for the U.S. Air Force, the Global Hawk is currently in service flying missions worldwide. In addition to Global Hawk, Northrop Grumman's HALE ISR systems include Triton, a U.S. Navy unmanned aircraft system with real-time ISR to cover vast ocean and coastal regions using systems designed to meet U.S. Navy mission requirements. NATO AGS, consisting of NATO-owned and operated airborne alliance ground surveillance systems that will provide vital ISR in support of collective defense operations, peacekeeping missions, and disaster relief efforts. And multiple NASA Global Hawks which support a wide range of NASA science and research projects. The HALE ISR systems enhance the military and civilian authorities' ability to prevail in all types of operations by providing near real-time ISR data using its high-resolution sensors or by providing a communications relay for operators in theater. And they do it in all types of weather, for mission durations greater than 32 hours. All of Northrop Grumman's unmanned aircraft systems are autonomous and operate like any other aircraft. They can take off and land from any prepared airstrip. Located at airstrips are ground control stations which are manned by experienced pilots. Here, pre-planned missions are uploaded into the system prior to launch, and after a thorough pre-flight checkout, ground crews begin the aircraft start sequence. Once communication links are established, the aircraft is ready to taxi and take off. Northrop Grumman's HALE systems climb to an altitude of over 50,000 feet in 60 minutes, quickly passing over dense commercial air traffic until it reaches its maximum altitude of 60,000 feet or 18,000 meters. For the duration of its mission, the aircraft operates high above civil airspace and does not interfere with commercial aviation. Additionally, high altitude provides other benefits such as operating above severe weather and high winds and outside of most threat envelopes. Upon reaching mission altitude, a communications link is established with the operations ground control station, which can be located anywhere in the world. Next, the command and control connection between the launch ground control station and UAS is released, and the operations ground control station takes control of the aircraft. U.S. Air Force Global Hawks are deployed to forward operating locations all over the world, such as in Guam, Italy, and within the CENTCOM area of responsibility. The U.S. Air Force controls all aspects of those Global Hawk missions from both Beale Air Force Base in California and from Grand Forks Air Force Base in North Dakota. The U.S. Navy Triton will operate out of 4 worldwide areas of responsibility: U.S. Central Command, European Command, Pacific Command, and Northern Command. With mission control out of Naval Air Stations Jacksonville, Florida and Whidbey Island in Washington State. NASA operates its Global Hawks out of the Armstrong Flight Research Center and out of Wallops Island, Virginia. And NATO's AGS systems will fly out of Sigonella Air Base in Italy. Frequently, there are multiple HALE UASs flying in different areas of the world at the same time, making the systems truly global. HALE UAS mission operations are conducted by a virtual crew. This virtual crew is made up of personnel at different locations around the world, connected by secure voice, chat, and email. The intelligence cycle begins when theater commanders or civilian authorities provide collection tasking requests to a HALE UAS operations center. The HALE UAS crew executes the mission to collect data from the requested targets and then forwards the intelligence data in near real time to intelligence experts for analysis and exploitation, or directly to operators in theater. The exploited intelligence data is then disseminated to the requesting user, who could be anyone from national agencies, troops on the ground, or first responders of a natural disaster. Actionable intelligence generated from a HALE UAS supports real-time decision-making around the world every day. A multi-intelligence Global Hawk was developed to provide long-endurance, day or night ISR in a multi-inch roll, meaning it carries both imagery and signals intelligence sensors simultaneously. Flying at mission altitude, the Global Hawk's Signals Intelligence, or SIGINT sensor, is capable of detecting communications or electronic transmissions from land or sea emitters at great distances. This capability provides the warfighter with detection out to the horizon, revealing any electronic emission from more than 300 miles away. And this data can be used to cue other Global Hawk sensors to pinpoint or identify targets. Data is also shared with exploitation centers who compile data with other ISR sources to gain valuable intelligence on targets. The Global Hawk Electro-Optical Infrared Sensor, or EOIR, can provide visual identification of an unknown target or visual intelligence of a large area of interest. This sensor provides both day and night capability using either electro-optical or infrared cameras. In other situations, infrared images show analysts hot and cold areas of a target and are used during day and nighttime operations. The SAR, or Synthetic Aperture Radar, provides the capability to acquire radar imagery of large areas at long ranges in any weather condition. The data collected by Global Hawk could also be provided through the theater commander as queuing information for other assets. Global Hawk can also be equipped with the MPR-TIP Wide Area Ground Surveillance Radar, which provides combat identification, target tracking, and time-critical targeting with both its moving target indicator and high-resolution SAR modes. The Global Hawk can continue to track targets of interest and provide continuous updates to the end users, tactical full-motion video platforms, and strike assets. And although capable of fully autonomous operations, Global Hawk's ability to be retasked on the fly allows the crew to meet ad hoc requests for emerging targets and unplanned missions needs, such as search and rescue or disaster relief. Over the course of a 32-hour mission, Global Hawk can produce vast amounts of intelligence for users worldwide. And as one Global Hawk leaves station and returns to base, another Global Hawk can take its place to maintain an unblinking eye, providing global vigilance. In addition to the traditional military ISR mission, Global Hawk is currently being operated as a communications relay platform. It can also be used for various civil and commercial missions such as border patrol, maritime and port surveillance, hurricane monitoring, disaster relief support, and high-altitude scientific research. Triton, whose focus is maritime, provides the fleet with a persistent long-range maritime ISR capability using advanced sensors that provide 360 degrees of coverage. Triton will deliver unprecedented maritime domain awareness. Once mission tasking is complete and the HALE UAS is within line-of-sight range of the launch and recovery ground control station, the command and control link with the shelter is established, and the satellite link with the operations ground control station is released. Coming home after covering more than 10,000 nautical miles, a HALE UAS can be readied and refueled for another surveillance mission anywhere in the world. As the current inventory of HALE UAS continue to collect vital intelligence and information all over the world, many new missions and advanced capabilities are being developed to ensure the HALE family of unmanned aircraft systems continue to provide value to warfighters and civil authorities across the globe.